Welcome back. In this video, we dive into the first building block of overall economic efficiency, exchange efficiency. We'll explore it through a simple two-person, two-good model. Let's get started. Exchange efficiency occurs when goods are distributed among individuals in such a way that no further mutually beneficial trades can be made. In simple terms, it means all the potential gains from trade have been used up. To understand this, let's look at the simplest possible economy. Two people, let's call them Anne and Burt, and two goods, food and clothing. The total amount is fixed. 100 units of food and 200 units of clothing. Now suppose we begin with an initial allocation and get 70 units of clothing and 75 units of food. Burt gets 130 units of clothing and 25 units of food. These starting points, called initial endowments, are assigned externally. But here's the key question. Will Anne and Burt just consume what they were given? Not likely. Why? Because this allocation may not be the most satisfying to either of them. They might both improve their satisfaction through trade. Trading can often move both to higher indifference curves, meaning more satisfaction. To analyze this, we use a diagram called the Edgeworth Exchange Box. In this box, the height equals the total food available, 100 units, and the width equals total clothing, 200 units. The bottom left corner labeled OA is Anne's origin. Movement to the right or up means Anne is getting more clothing or food. The top right corner labeled OB is Burt's origin. But here's the twist. Burt's preferences are rotated 180 degrees. So moving left from OB means Burt gets more clothing, and moving down gives him more food. Every point in the box represents a complete allocation of food and clothing between the two. Nothing is wasted or left over, just reshuffled. If Anne and Burt find a point in the box that makes both of them better off compared to their initial endowment, they'll agree to trade, and they'll keep trading until no further gains are possible. That final point is exchange efficient. No one can be made better off without making the other worse off. At this point, their indifference curves are tangent. That means their marginal rates of substitution, how much they're willing to trade one good for another, are equal. And that's the condition for exchange efficiency. MRS for Anne equals MRS for Burt. Let's look at one such point. Call it point R, representing their initial endowments. At R, Anne's marginal rate of substitution, how much clothing she's willing to give up for food, is much higher than Burt's. That difference is what makes trade worthwhile. All the points inside the lens between their indifference curves represent allocations that both prefer to R. One such point is T, but even that isn't the final destination. After enough trading, they can reach point M, where their indifference curves are tangent. At this point, Anne's marginal rate of substitution equals Burt's marginal rate of substitution. No further gains from trade are possible. This point is Pareto efficient, meaning you can't make one person better off without making the other worse off. Now, in fact, there are many such points, every place where the two indifference curves are tangent. These points together form the contract curve. It represents all the Pareto efficient allocations, where trade has exhausted all possible gains. Great! But in the real world, Anne and Burt don't sit down and bargain personally. In modern economies, markets handle the exchange through prices. Let's suppose they begin at point E each with 50 units of food and 100 units of clothing, and prices for food and clothing are equal. Price of cloth divided by price of food equals 1 inch. At this price ratio, each consumer has a budget line going through E. If Anne sells food, she moves down the line. If she sells clothing, she moves up. Same for Burt. His movements follow the same price slope. But here's the issue. At this price ratio, market demand doesn't match supply. There's too much demand for clothing, too much supply of food. This situation is not a general equilibrium. Something needs to adjust. Here comes the invisible hand. Markets adjust the price ratio. In our case, the price of clothing rises relative to food. A new price ratio, say 6/5, brings the market into balance. At this price ratio, both consumers' optimal choices, where their indifference curves are tangent to the budget line, match exactly what the market can provide. Now we have MRSA equals PC/PF equals MRSB. Market's clear. Supply equals demand. To summarize, these are the conditions for exchange efficiency in a market. Equal marginal rates of substitution for all individuals. A price ratio that matches those MRS values. Budget constraints are respected. PC increments 1 plus PF increment F1 equals 0 inch. This ensures that the equilibrium is not only efficient, but also affordable. So market prices guide individuals to efficient outcomes, even without direct negotiation.